I became an engineer to make a difference, and over my career, I think I've achieved that. I've worked on hundreds of projects that have made a positive difference to people and communities, and that is very fulfilling work. I'm very proud of that. But what I've come to realise is that those projects also emitted carbon dioxide, and they contributed to climate change. Through our work as civil and structural engineers, we can actually make a huge difference in reducing carbon dioxide emissions, far more than we could ever make in our personal lives, and more than companies can make in running their own businesses. So I really see this as a time for the engineers to rise to this challenge and use our ingenuity to solve the problem. Over the past 20 years, the government has focused on reducing operational energy and operational carbon emissions. So the energy and carbon that's emitted during a building's use, so the lighting, the heating systems, things like this. And that's been a success. The operational carbon has reduced. But the government hasn't really looked at embodied carbon dioxide emissions, and that's all of the carbon dioxide associated with making the building and with maintaining it and with demolishing it at the end. So this is now a very significant piece of the carbon dioxide emissions pie chart, as it were. And it's standing out to me because I'm a structural engineer and I know that I can make a big reduction in that chunk of the pie. But we do need our clients to be on board. I've been trying to sell this for 10 years and no one's buying. Most clients, unless they're public sector, they tend to have a short-term view on their investments. They want to develop and sell, make a profit, move on to the next site, and that's business. That's enterprise at the end of the day. And so I do think we need the government to legislate, just like they did for the operational energy. I think they need to legislate for the embodied energy and the embodied carbon dioxide. I can persuade clients, but I'm one person. We need to be very persuasive with clients that are maybe looking at the bottom line and maybe help to show them that the building that can last longer, to be built with less and be more resilient, more adaptable and last longer is worth more. It's early days. The industry is really testing and experimenting with what is possible. We have modular construction and pre-manufacturing, which isn't exactly new to the industry, but has never been done on a mass scale that we would need to reduce embodied carbon emissions. So many different forms of modular construction and modern methods of construction. And then there are new ways of building with concrete and bricks and steel and timber that maybe we need to try and embrace and advocate for and persuade our clients that this is going to be a good way to go forward. And if we can measure the embodied carbon after the project has been constructed, we can obviously demonstrate the benefit. And hopefully there will be more of a benefit than just carbon dioxide. Hopefully there'll be cost benefits in the long term, because it's logical that if you build with less, it should cost less. We have the skills to do this, absolutely we have the skills for it. We just need to put our skills to use rather than following the tried and tested methods that we all are very comfortable with. In fact, young people today are choosing engineering as a profession because they're getting concerned about what the grown-ups are going to do about climate change, and they want to come in and make sure that they can take control of their futures, that the next generation will be full of passionate young engineers that want to make a difference to the planet in a way that I felt when I was a graduate engineer, because I do think that the time for that is now. It's really now or never. So it's time to build less, reuse more, and to make our buildings last longer. In other words, to sustain.